review number 1. So here we go. Number 1 says, find the removable discontinuities. Guys, remember that removable discontinuities are holes. So we are finding the holes in this function. So obviously we're going to need to factor it. So I'm going to pull a 2 out of everything on the top and a 3 out of everything on the bottom. And then I'm going to factor everything. Now I got to keep the 2 and the 3. They're going to be important here in a little bit. But I'm going to go ahead and factor this trinomial. And as I keep saying over and over again, take a moment and either physically or in your head, FOIL this back together to make sure that you've got the correct factoring. Same thing on the bottom. Just take a quick second to double check that. Now, in order for there to be a removable discontinuity, you need to be able to cancel, and we can. So we're canceling out a 2, which means our whole is going to be at 2 comma something. To find the something, we are going to plug that 2 back into our remaining equation. Now, our remaining equation is 2x plus 1 over 3x plus 5. So when I put the 2 in here and here, I'm going to get 2 times 3, which is 6, and I'm going to get 3 times 7, which is 21, which reduces by 3's into 2 7's. So my removable discontinuity is at 2 comma 2 7's. Okay. Next, I'm going to solve a little rational inequality. So I'm going to start by getting a 0. I got to have a 0. So I'm going to subtract that 2 to the other side. Bring that 2 over. And I'm going to think of it as a fraction because I'm going to have to get a common denominator. So to get a common denominator, I'll multiply the top and the bottom by x minus 3. So that my denominator now matches. So I'm going to write one fraction that is x minus 3 on the bottom. And then the top is going to be x plus 5, careful, minus 2x plus 6. Watch it up there, negative 2 times x, negative 2 times negative 3. Now let's clean that up. Negative x plus 11. Now I can go to my number line. Be careful. The 3 dots going to have to be open, remember, because dots that come out of the denominator are open. And that negative messes me up, and I want to be careful, so I'm going to go ahead and set that equal to 0 so that I can see my top dot is at 11, closed in, and my bottom dot is at 3, open. Now I'm going to pick a number, and I can pick any number I want except these 2. So I like 0. For me, 0 is the easiest thing, so I'm going to pick 0. 0's out here. So what I'm doing is trying to figure out if I'm going to shade out here. So I'm just going to put 0 back into my fraction, and I get 11 over negative 3. Is that number bigger than 0? Is 11 over negative 3 bigger than 0? No. So that means I don't shade where the 0 is. I shade here instead, and not there. So my answer is 311. write the equation of a logistic function. All right, so I'm going to stop right there and remember that looks like a over 1 plus bc to the x. That's the format I'm using to write my logistic functions. 3 variables, I don't know what any of those numbers are, but I have to figure them out. And luckily, I have been given 3 pieces of information to help me find these 3 variables. So the first thing my BV lies are zeroing in on is the limit to growth is 15. Now remember, the limit to growth is your numerator as long as that number is a 1. And since I set it up as a 1, I get to use 15 as my numerator. No work, I just plug it in. That's the limit to growth. Now, the next thing that's important for me to know is the initial value is 5. The initial value, remember, comes when x is 0. It is your y-intercept. It's where everything starts. So I know that if I put a 0 in here for x, I'm going to get a 5 here. Now, I know that anything to the 0th is 1. So now my equation looks like this. That's 1. This right here is 1. So now I can cross multiply. So 5 plus 5b equals 15. 5b equals 10, and it looks like b is 2. So now I figured out that a is 15 and b is 2. So now my equation looks like this. b was 2. So luckily, I have one more piece of information. I contain the point 2 comma 15 ninths. So 15 ninths, is it ninths or 19ths? 19ths is my y, and 2 is my x. So I'm going to, got some bad arithmetic here, so I'm going to cross multiply. So cross multiplying is going to give me 15 plus 30c squared. I cross multiplied here. And then 15 times 19 is 285. Okay? So now I'll subtract 15. So 30c squared equals 270. Dividing by 30 gives me 9, so C must be 3. So the answer to my question is y equals 15 over 1 plus 2 times 3 to the x. That is your logistic function. Now, there are a lot of steps to that, but it's easy and they're always the same. So you can go back and redo this problem or problem that's out of the notes as many times as you need to. Now I'm going to describe the end behavior of an exponential function. So I have 0.7 to the negative x. Now there's 2 things wrong with this. First of all, when I examine exponentials, I really want that to be bigger than 1, especially when I've got a negative exponent up there messing it up. So I am going to choose to rewrite this. That's 7/10. So I'm going to think of it as 10/7 to the x. this number is bigger than 1. That's a positive x. This is a regular growth exponential. Now, another way you can think about that is 0.7 would indicate decay, but a negative exponent would indicate a reflection. So if you started with a decay, but then did a reflection, you would end up with a growth. Kids, it makes absolutely no difference which way you think about it, because ultimately that's not the question. Ultimately, you need a picture so that you can describe the end behavior, which simply is asking you what happens on the left side of the picture and the right side of the picture. On the right side of the picture, right here, x goes to infinity. On the right side of the picture, this curve is going up boundlessly. There's nothing limiting it. It's going forever. On the left side of the picture, the curve is approaching its asymptote, which is 0, from the top of the asymptote. That is the end behavior, which comes straight from this picture. So how you get that picture is up to you, whatever logic works for you, but you've got to understand that this curve looks like this. And finally, we're going to evaluate a little exponential without a calculator. All right, well, that shouldn't be too bad. So it says find f of -2. So we're simply going to plug -2 in for x. That's how you evaluate functions. You put in whatever for x. So then we got to remember that exponents always happen before multiplication, PEMDAS. So we're not going to do any multiplying here. We're going to clean this up first. 2 to the -2 is 1/2 squared, because remember, negative exponents flip you. 1/2 squared is 1/4. So the answer to the problem is -1/5 times 1/4, which is -1/20. And that's that. We'll review 2.